Okay, 2.1 day one. Today we're going to talk about functions, domain and range, and some challenge problems. Can you hear me through the speaker? Is it working? It's not working. Is it? Let me turn up the old volume. Hello? Let's pause this. We have already returned tests. Let's continue on with 2.1 day one. Students are able to find domain and range, known and variable quantities. Okay, as we know, functions are part of the relation family. Therefore, all functions are relations, but not all relations are functions. Pause. Okay, everything you see up here right now with all this crazy like F colon X maps to Y, all this stuff, this is all just verbiage for functions. Functions, functions, functions. So all that this means is some function F such that all the x's in the domain map to these values in the range. So y is kind of like our range, and x is like our domain. And I believe I'm not even moving. Maybe if I move, it'll help. There we go. Okay. Same thing. I have no idea where I was, so I'm just going to keep talking. So our y, right, you'll notice that this y is lowercase, whereas that y is uppercase. It's just mathematical lingo for here's a function y equals, here is the range or the outputs of whatever that function was, okay? I wouldn't necessarily spend a whole lot of time focusing on the language of it, but more the mechanics of what we're about to do, okay? So this statement here, f is such that the set of x maps into the set of y where f of x is equal to. So it's just domain and range, it's fancy language for that. Don't get too bent out of shape there. This symbol here just means element of. So you might see something like x is an element of z plus. That's just the positive integers, z plus. If I said z minus, that's just the negative integers. And if I just said z, that's all integers, positive and negative. Okay? It's just a mathematical language. Let's continue on to the next slide here. So there's three ways to determine whether or not there's a function. Okay, we've talked about one of them last week, actually two. We said let's take these ordered pairs here and let's compare, right? And let's see if any one x value gives us multiple y values, right? And then we have failure of the second method, which is vertical line test. So right here I see 1, 5 and 1, 3. If I were to sketch that, that would fail the vertical line test. Okay? We just want to figure out, based on what form it's in, does it fail the vertical line test? And in this case, this would not be a function. No. That's Spanish for no. Okay, yeah, I'm pretty good. In the second method, of course, looking at a graph, it's fairly simple to look at a graph and determine, does the vertical line test fail? There's many different ways I could try to trick you. We'll see those in a little bit. The third way that we can determine whether or not a relation is a function is when we simplify it, does it have only one rule? Right? Does it have only one rule? If I simplified this for y, I always want to have y equals and have only one rule. But if I do that, I'd have x minus 4 equals y squared. Okay, I've moved both the y squared and the 4 at the same time. And then I take the square root of both sides, and I get the square root of x minus 4. However, when I take the square root, I get two answers, and therefore I have two separate equations, right? This is y equals the square root of x minus 4, and y equals negative square root of x minus 4. So if I were to sketch that, we would clearly see that the square root of x has been shifted which direction? What does this 4 tell us? Which direction did that function get shifted? Up or down, left or right? Right, correct? Right 4. So 1, 2, 3, 4, and there we go. I've got y equals positive square root of x minus 4. I also have y equals negative square root of x minus 4, and therefore obvious failure of the vertical line test at 2 points. So if your function turns out to have 2 different equations when simplifying for y, we have a problem. What would maybe be a good indication, good, I am recording, looking at this, that there's going to be multiple equations. Yeah. There is a square root. But even before that, before I do any of this work down here, if I just look at the original equation, y is 2, yep. Yeah, there's an exponent. But that exponent has what kind of power? Even, right? If I have an even power, then that's a good indication that I'm going to have issues, right? Because when I square a negative, I get, obviously a positive back again. So, Henry, thank you very much. Thanks for the assist. All right, I'm going to pause the video. I want you and a neighbor to take 4 minutes, 4 problems. Not even that. 2 minutes, 4 problems. 30 seconds per. Talk to your neighbor. See if you can determine which are functions and which are not. Go. So the square root scares you. Why does the square root scare you? Because you can't divide by 0? Is that what scares you? Because you can't. Only, 2 people can. Right? Bruce Lee and Chuck Norris. They can divide by 0. But they're not in this class. That is a function. It is. Right? The moment I put plus or minus attached to it, then it's not. Right? Because then there's multiple values that can show up. I can plug in any x value, and I get only one y value out for that x value. So number 2 is yes. So I got a yes here. I get a C here. I better put the little schmilde or whatever they call that. Oh, that's a yes. It's just poorly drawn. It's just poorly drawn. Be nice to me. Number 3, function or not. Negative, Ghost Rider. The pattern is full. If I were to write this, y squared equals x squared minus 4x minus 12, and then I want to simplify, so I would have to take the square root of all that garbage, right? I'm going to get 2 possible answers for each input. Okay, and then the last one. I heard a yes and no out of the same mouth within 6 seconds. Was it you, Maureen? Oh. It is no. It is no. 3 is no. Correct. 3 is no. And 4 is no as well. If I were to sketch this relation, x is always equal to 3, and y can be anywhere between negative 2 and 7. So x is always 3, and y can be between, what was that? 7, negative 2. Open line connecting. Not a function. Cool. Lesson 1 is pretty easy for today. It's just making sure you pay attention to details. Okay, so let's go through here real quick. Let's just do a vertical line test and determine whether or not these are functions. Okay, I'm just going to randomly start over here somewhere. Eddie, this one up here in Washington, state of Washington, function or not? Definitely not, right? No. Could we still determine its domain and range? Yes, but typically we don't, okay? We'll come back and do domain and range in a moment. Let's see, Scott, how about up here in Maine? Yes, passes the vertical line test, great. Graphs are awesome, guys. That's why we love pictures as little kids and books. And when we're adults, we also like books that have pictures. And when we're old. Oh, this is actually recording. Okay. How about this chunky looking graph? Here's a chunk, here's another chunk, here's another chunk, etc. Right? Is that a function? It sure is. You know what that looks a lot like to me? The secant graph. What? Watch this. You ready? Doesn't this look a whole lot like cosine? If you take 1 divided by cosine, wherever the cosine equals 0, if I take 1 divided by cosine, wherever the cosine equals 0, the reciprocal function will be undefined. Oh, sick. So that's the reciprocal of cosine. It's called the secant function. What's the x? That's like our input, right? Yep. So that's called the secant function, all right? Is it a function? Why, yes, it is. We'll come back to that in a minute. Function or not? Heck yes, it's a function, right? It passes the vertical line test. Let's go back and talk domain and range. Domain is all possible inputs. Okay, I'm going to pause this. Let's talk about it. And those of you who are at home or visiting us online, you can check it out. Something here. There you go, folks. Visiting online. That's our domain. That's our range. We'll be back. It's probably awkward how quickly I went from one problem to the other without even writing it. Yes, we're that amazing. Okay, here's your domain. Here's your range. Notice at y equals 0, there's a gap, hence this gap right here. And at x equals -1, there's also a gap, and that's that gap. Where is the cosine equal to 0? Well, the cosine equals 0 at pi over 2. This is new knowledge to you probably. And then we add pi each time to get to the next one. Okay, so this is really weird. I'm gonna write something and it's not gonna make much sense, and it's okay. Just stick with me because we'll eventually get to this kind of stuff. So my domain is everything except for those values. Okay, so here's what I'm going to say. I'm going to write this in actually set builder notation. X such that x equals pi over 2, right? Isn't that my first asymptote? Plus or minus pi k such that k is an element, of the integers. What? All that means is this. X equals pi over 2, it's a gap in the domain. Then I can add pi as many times as I want, or subtract pi as many times as I want, and that maps out all of the asymptotes forever in both directions. Instead of this is what a child last year did. For those of you online, sorry, you're going to miss this. Folks up in the cloud, I changed this right here to not equal to, because those are the values that are not possible inputs. Okay. And the last one, domain. Where is this? -3. It can't equal -3. And we go all the way over to 1. It can equal 1. My range from, what's the lowest value here? -4 up to, looks like, oh, now this is in question. Is it 0 parenthesis or bracket? Bracket, right? Because we do have one value right here where that output is satisfied. So I'm going to use a bracket. There you go. Thank you very much. Okay, so I got a function. We're going to call it 3 minus x squared. And instead of x, I'm going to plug in c. Oh, that's easy. So I'm going to plug in, instead of x, I'm going to plug in c. So it looks like I get 3 minus c squared. In part D, I only have 20 seconds left, so this is going to be interesting. I'm going to take, and instead of plugging in x, I'm going to plug in c plus 1. I'm going to square that. Well, that's going to take some work. I got a FOIL, right? Our favorite four-lettered F word, FOIL. Yeah. Okay. Pause. That's your answer. Children, this is your answer.